talked about AR process and distributed lag models, and now we learn how to convert this to, and this could be converted to ARDL, where we have the autoregressive part. So we have YT. So we could have a more general case now where we have YT depends on YT with lags here. So it is regressed on itself. So the first part is our AR process. The second part here is the distributed lag process, and that model is called ARDL. So autoregressive distributed lag model. So because it includes both, it includes YT in lagged values, and then and also the X as well. So this obviously captures the dynamics of both. So that's more general compared to the one that we saw in the previous in the first half of the lecture. So that captures both the dynamics of Y and the dynamics of lagged Y's and the dynamics of lagged X. And of course can eliminate autocorrelation because you could include the lagged values. So let's have a look at some example. This is a very simple example of inflation. Okay, so inflation rate in time t depends on inflation rate in time t minus 1. So remember that's yt minus 1, and that depends on unemployment rate in time t and unemployment rate in time t minus 1. So this is a very simple ARDL model. We have one lag, one p equal 1, or the number of lags for the y is only 1, and we have one lag for x, so it's 1 1. So ARDL 1 1. So p equal 1 and q equal 1. So that means one lag for the dependent variable for y and one lag for x. So estimating this model, that gave us, these are the estimated coefficients. This is the yt minus 1, or inflation in time t minus 1, and this is u, or the change in unemployment rate in time t, and this is the change in unemployment rate in time t minus 1. So L here is just the lag operator. Rather than saying t minus 1, I just added L. This is the difference operator. So that means is the first difference. So it's the change. Yeah, and you see these all significant again. So the difference here, or the comparing this to what we covered earlier, you've got both in the model. So you have yt minus 1, which is inflation t minus 1, and xt and xt minus 1, which is the change in unemployment rate in time t and t minus 1. Okay, so this is more general case where we have both in the model, so the AR process and the DL, or distributed lags, and that was a very, very simple example. So this is the first topic I wanted to cover today, just to introduce you to some examples of dynamic models where you can include either lags of y or lags of x, or you have both together in one model. So you could have AR model, okay, so the autoregressive model where you have yt depends on yt minus 1, yt minus up to yt minus p, or you could have the distributed lag where you have yt depends on xt and xt minus 1 and xt go back up to q, or you could have the ARDL model where you have both. You have yt depends on yt minus 1 up to p, yt minus p, plus xt minus 1 going back to xt minus q, plus an error term, which is the ARDL model. So these are the examples I wanted to look at quickly in this, or briefly in this lecture.